All right, guys, we're going to make a little video here on graphing polynomials in factored form. And just keep in mind that when we talk about factored form, we're saying that we have, the polynomial written with its factors listed, not to be confused with expanded form, right? Expanded form, or maybe you might see something like, right? So this is expanded form, and this is factored form. All right, let's get moving. As I go through this video, don't be afraid to press pause and to catch up or to go back and re-listen to things more than one time. So let's take a look at the instructions. First, we're going to be sketching, right? Not a perfect picture, but a nice, accurate sketch. And the first question we want to think about, right, as we're thinking about things when graphing, is the degree of the polynomial. So the degree of this polynomial, we have x squared, so that's a second degree, x to the first, at another degree, that's a third. And we have x to the third, it's another degree. This is a sixth degree polynomial. And that's even, so I know that my end behavior is either both up or both down. That depends on the sign of my lead coefficient. So I kind of feel like these two items are in reverse order. I want to think about that sign of the leading coefficient. So let's take a look and think about it. So this is a positive 1x to the third times a positive 1x times a positive 1x to the third. So I guess I'm going to get a positive 1x to the sixth at the end of the day here. So when I expand this thing, I think I would have f of x equal to 1x to the sixth and some other stuff trailing. And the big deal is that that's a 1 and that's a positive, right? So the sign is positive, so the end behavior is going to be up and up as I moved from negative infinity to positive infinity, right? So I know something like that so far. The next thing I want to think about as you get to the end of this polynomial, what is that constant, right? That y-intercept. And that's going to be the value of x, the value of y when x is 0. And if you think about that, well, out here is 0 squared, which is going to be 0, times this, which is -2 and -7 to the third. But I don't even care what any of that is because 0 times all of this is going to wipe it out. So this is going to be a big fat plus 0, meaning this thing goes through the origin. So the y-intercept is 0, 0. The roots and their multiplicities are also very easy to think about in this term, right? So our root here is 0 with a multiplicity of 2. So I'll say a multiplicity of 2. And then I have positive 2 with a multiplicity of 1 or no multiplicity. And then positive 7 with a multiplicity of 3. So there are our 3 zeros, or roots. Okay, so one thing to think about is the behavior that we've learned about from the last video in terms of multiplicity. So we know that this x squared is what we're going to have a sort of touch and turn. And I know that I'm ending out like this, right? So I know from here on out it's going to go this way. I know from here on out it goes this way. And at 0, it touches and turns. It has to go back down and turn somewhere around in between. And then it has to flex through that last moment because that's an x to the third. So if that's what happens, then I think we're in pretty good shape. The question is, where does that max out? Probably somewhere in the middle here, so it hops over. Then I think somewhere along the lines, I'd like to know where things are happening down here. So maybe some points might help us figure that out. Now this is not a 100% necessary function. It's just kind of driving home the point that if we go a little left of the 0 here, that 0 of 0, to a value of -1, we go all the way down to up to positive 1536. So like 1,000, like huge. And then when we move to the value of 1, in between the two zeros, we go to a value of 216. So if this is 1500, maybe that's like right around here. And then at 4, we go down to negative 864, so maybe like halfway-ish. And then flex through and then back up to like 300 and change over here at 8, right? So what does that look like? A little something like this. And so what do we notice? We're coming down from that high moment here at negative 1. Boom, we hit 0. We bounce off of 0. How do we know? Even multiplicity, that has to bounce or touch and turn. So it touches the 0, jumps up to a point, sort of arbitrary, not arbitrary, but roughly to scale. And I come back down to this 0. I go through it because that has a multiplicity of 1, so that means I go through. Down to a low point here, which I just kind of ballparked by substituting in these values, right? I just did this for added bonus to make it a little bit more accurate. I know that at 7, I'm going to flex because that's an odd multiplicity greater than 1, which indicates a flex. And then I had thrown in a value for 8 at around 300 just to kind of draw it to scale. And for a 6th degree polynomial, I know I can't have more than 5 bends. So we got 1, 2, 3, 4, 5. So we're in good shape here. And we're both heading off to infinity. As x moves to the left and to the right, looks like a good sketch. Let's try again, but just go a little bit more swiftly. Don't be afraid to press pause and catch up with the notes as necessary. Our next example, right off the bat, strikes me as no multiplicities, right? So these are all x plus 8 to the first, x minus 5 to the first, so on and so forth. So answering these questions should be pretty easy. And so we start looking at the degree. So this is going to be x to the first times x to the first times x to the first. This is a 3rd degree polynomial. That means that this is an odd. So it's either going to be a positive odd or a negative odd, right? This is a positive version. That's a negative version. Our end behavior then depends on the sign of the leading coefficient. It's a positive 1, positive 1, positive 1. So that's going to be positive 1x to the 3rd as we think about this in terms of expanded form. So the sign of the leading coefficient is positive. The y-intercept is going to be the value of y when x is 0, which leads all of these numbers to be 8 times negative 5 times negative 2. Negative 5 times negative 2 is positive 10, and 8 times positive 10 is 80. So our y-intercept is 0, 80. And then the roots are going to be negative 8, positive 5, and positive 2, all with singular multiplicities or no multiplicity. I'm going to go ahead and use a y scale of 20. So this will be 20, 40, 60, 80. So there's my 0, 80. And then we're just going to go ahead and draw our sketch. We know we're coming away from the bottom. It has to go up, down, and something like that. And just one last thing to consider before we walk away from this problem. If you trace the value of x of negative 4, which would be right along this location, right, you get a y value of positive 216. So let's just call that 216 for now, right? And I know that doesn't really agree with my scale. And then I come over here to x of 3.5, which only goes down to negative 25 and change, right? Call it negative 29. My argument is just, this one's way higher than this one. And so I just want to make that sketch sort of observe that fact. Okay, let's move on. In our next problem, we see that we have two multiplicities of 2, right? So 2 touch and turns, so to speak, or 2 touch and turns like this. Not sure which way it goes. And those happen at negative 2 and positive 4. So it has a multiplicity of 2 and a multiplicity of 2 on both of those. I know that my degree, therefore, is a 4th degree polynomial. I don't see any negatives happening here for the x's, right? So what that means is that those are both going to become positive when I square them. And positive times positive is going to be a 1x to the 4th. So since that's a positive coefficient, I know that the end behavior of this thing is going to be up and up. So that's this version right here. The y-intercept is going to be, put a 0 in for x and x. That's going to be 2 squared and negative 4 squared, which is, 2 squared. Sorry, I had 4 in the brain. So that's going to be 4 times 16, which is positive 64. Don't forget, negative times a negative is positive, and that's going to be 0, 64. Okay. So I know coming from my left 0 and my right 0, this thing's going to go up and out like that, not necessarily at that angle. And I do know that it's going to touch and turn and touch and turn, and I know it's going to hump in between like that. It might be just nice to see how high that thing goes. And that's going to happen halfway between 2 to 4. So that's at a value of 1, right? 3 hops to the left is 4. 3 hops to the left here is negative 2. So it might be nice just to go to an x of 1 and figure out the y value that's associated with 1. So it's 1 plus 2 is 3 squared. And 1 minus 4 is negative 3 squared. So that's 3 squared is 9, and negative 3 squared is positive 9, and 9 times 9 is 81. So that's not that bad to figure out. Just helps in drawing a reasonably accurate sketch, that's all. And so there's the drawing. A touch and turn at negative 2, right here, and a touch and turn at positive 4. And you can say, well, what if I didn't want to make my y scale equal to 10? Well, what if I wanted to make my y scale at 20? Right? And I'm going to draw that one in red. I'm going to say, okay, I'm going to make it a 20. Well, then this would have been 20, 40, 60, 80, and my picture would have went like this, right? Which one of those is better? Yes, right? There is no better. It's just trying to decide, to give a little bit of accuracy, right? Give a little bit of detail and accuracy to your picture. That's all. This last one looks a little scary, but nothing to be too concerned about. This negative 1 over 5,600 is just a big fractional negative lead coefficient, right? So my lead coefficient, the sign is negative. No big deal. And then I have a, looks like a touch and turn, a singleton strike through, a flex, and then another singleton strike through. So we're going to go through, we're going to flex, we're going to touch and turn, and we're going to go through. All right, let's get to it. So back to the beginning, we have a x squared, so that's a squared, plus another singleton x, plus an x to the third, and plus another single x, so that's 2 and 1 is 3, and 3 is 6. This is a 7th degree polynomial. So again, it's odd, so it either ends up like this or like this. This would be if it's positive, this is negative. We already said that that was a negative lead coefficient. So the behavior is it's going to come down from the top left and go out at the bottom right. The y-intercept is going to be this value times 5 squared times 1 times negative 4 to the third times negative 7. For that I get 0, negative 2. So that wasn't so bad. The roots and their multiplicities we're going to have starting from left to right. That's going to be negative 5 with a multiplicity of 2. We're going to have negative 1 with a multiplicity of 1, so I just write 1. We're going to have positive 4 with a multiplicity of 3, right, a flex. And then we're going to have 7 with a multiplicity of 1. And just for the record, again, we're going to have this idea of coming down from the left and going out on the bottom right. Okay, so I've plotted my zeros, and I took a little value at negative 3. So at x at negative 3, that value goes to approximately positive 4.9. So let's call it approximately 5. So that's 1, 2, 3, 4, 5, right around there. So I just wanted to say that it touches and turns there, comes down here, goes through 2, flexes, and back down like that. That much I know for sure happens. Now this area here may not be the best description of what's going on. I was trying to really accentuate that flex, right? So I know I have a flex here. I know I have a bounce or a touch and turn here. I know my y-intercept was at 0, negative 2. So it's a reasonable graph. So maybe if I were to come in as a teacher, I'd say, hey, well, maybe try to make that a little bit nicer. But in the grand scheme of things, that's a pretty decent sketch. What your charge is now is to try to do this on your own. But in order to do that, I think you need to be answering these questions, right? What's the degree in the end behavior? What's the sign of the lead coefficient, the y-intercept, roots and their multiplicity? You have to be able to answer those questions to get yourself a nice, accurate sketch. So I'm going to walk you through just one last one. Before I do that, why don't you press pause and try to answer these questions on your own, get an accurate sketch, and now you can gauge to see whether or not you can do this on your own. So press pause, do this question, then press unpause and check your answers against mine instead of working with me. Press pause now. Okay, so how'd you do? I knew that at the origin I had a bounce, right? A touch and turn. I knew that I had the top out here because both ends had to go down, right? I had to go down on both of my ends, right? This was a fourth degree polynomial, which means both ends go in the same direction like goalposts. I know that it went down because the lead coefficient was negative. I knew that my y-intercept was 0 because when I substitute 0 here, it's going to wipe out everything. So at the origin, I knew I had a touch and turn, right? A bounce down. And this point right here, just for the record, is around 3-ish. So I went up, through, back up to that point where I touch and turn, back down, put my arrows, boom, done. Your mission, should you choose to accept it, and you will, is to complete the rest of the homework on your own. Then turn that in. Best of luck.